If you need any good shirts or mugs, everything that we have here on the site comes as a, your choices are, you've got choices of colors, we've got hoodies, long sleeve, and mugs if you want a mug, a coffee mug, or a gift for somebody. Everything does, if you buy 2 shirts or hoodies from my store, you will end up getting my videos on SAT and ACT prep, and I've got quite a few of those, so take advantage of that if you like. And if you like my videos, please be a subscriber and hit the like button. Thank you so much, and here's today's video with homework help on parametric equations. Okay, I wanted to talk about this question that I saw in Math Excel, and so I thought I'd create this video. A person hits a baseball that's 3 feet above the ground with an initial speed of 150 feet per second and an angle of 16 degrees with the horizontal. Okay, so we're creating 2 equations here. We have 150 is the original velocity, and because we're dealing with the x-coordinate, we need to talk about cosine. And this is the coefficient of t. This is the whole distance equals rate times time thing. Your rate is 150 cosine 16. And we want to set that equal to 350 feet away, and that will allow us to figure out how much time. So we can literally calculate this number right here, the 150 cosine 16, and divide it to the other side. And of course that'll cancel out and leave me with 350 divided by parenthesis 150. Yeah, put parentheses around this if you're going to try this with me. And I ended up with 2.427 seconds. Okay. That now gets put into the other equation, which gravity is the first part of the equation, deals with gravity. And then you have your velocity in terms of the y values, okay, times t, plus, now, the original height was 3 feet off the ground. So let's see here, negative 16, and then that's, I'm going to use, for t's, I'm going to use ANS. Because I don't want to retype that number in. So, answer squared plus 150 sine 16 times answer plus 3, and I got a y value of 9.087 feet. Now, the ball needs to clear a 50-foot wall. Well, we're only, at a 350 feet, we're only 9 feet off the ground. So that's where this number came from. So explain why the person's hit might be caught by an outfielder. Okay. So how high up the wall does the ball hit? Okay, so it hits at 9 feet. So I guess I was thinking that they were asking if it was going to be a home run, but it's not. They're asking, is that catchable? Well, there are lots of people, lots of taller people, athletes that can jump to 9 feet and catch a ball with their outstretched hand. So that is definitely doable. But on part C, it says explain why the person's hit would likely not be caught by an outfielder if we changed it to 22 degrees. So if we go through this process again and change it to 22 degrees, so all we're going to do is we're going to alter this to a 22, which is obviously going to change that, and we'll alter that to a 22. So I can quickly try to go through this again. 150 cosine 22. That gives me 2.517 seconds. Okay, and then do the same thing. And change that to a 22-degree angle. We end up with 43.078 feet. It's a little bit hard for somebody to jump up that high to catch that ball. So anyway, that's what they were getting at with that particular question. So they also, in this next question, this could be a graphing question. I'm not a great fan of the graphing because what they're going to basically have you do is guess, well, how many feet do you think it's going to be before it hits the ground? Well, maybe I'm going to guess 200 feet before it hits the ground. Well, how high do you think the ball is going to go? Well, maybe you think it's going to go to a height of 50 feet in the air, or maybe you think it's going to go to 100 feet in the air. And then how long, how many seconds you would have to guess, time 10 seconds, say, oh, okay, well, I'm going to make the max for the time 0 or 10 because I think it'll hit the ground before 10 seconds. Well, so the interesting thing is this ball is going to go up and it's going to come down, okay? Well, right here it's going to have a y value of 0, right, at that spot where it hits the ground. So we could literally take our y equation, right, which is, let's see here, negative 16t squared plus our original velocity is 66 cosine 32. Oh, why am I doing cosine? Somebody stop me. Sine 32 t, and we want to set that equal to 0. Well, from our days in factoring, we can see that both of these terms have a t in them, so you can pull that t out, giving me negative 16t plus 66 sine 32 equals 0. And so you would set both of the factors equal to 0. Well, the first one's easy to set equal to 0 because that's when the ball was hit, times 0. It's this other one that I really want to pay attention to, negative 16t plus 66 sine 32 equals 0. This would only happen if 66 sine 32 was equal to positive 16t, which would only happen if t was equal to, alright, so 66 sine 32 divided by 16, use parentheses around the top if that's what you're choosing to do. So we got 2.186 seconds. Okay, so obviously 10 seconds was way big on a graph. And then you could plug this into the x equals cosine, oops, sorry, I forgot my 66. 66 cosine, what was the angle, 32 times, and I'll just use that answer feature again so I don't have to type in the 2.186. So 66 cosine 32 and then put answer. And I ended up with 122.35 feet, which is where they got this answer, 122. Now, if I change it to 55, then that means all you're going to be doing is going through and changing this to 55, all the way through, all the way through, all the way through. Oops, sorry. That's where you would get a different answer here, and that would be 55, And once you get that different answer here, you're still using this kind of thing, and in this case you get the other answer, 128. So the algebraic way is more accurate. The one thing I don't like about the graphing, even if you do get the right window, it makes you kind of guess and check, because if you go to the calculate, there's no calculate zero feature. So it kind of makes you guess. Now, could you calculate t and then plug it into the graph? Sure, but that's no better than what I just did. Anyway, doesn't save you any time. Okay, just thought I'd show you that video of those two questions from today's help session that I thought were more difficult.